Good evening, everyone. So, timber as a structural material is adopted because it's renewable, abundant, and aesthetic. And also, there are different engineered products available in the market, such as glue lam and CLTs. So, the role of structural health monitoring in the timber structure is because it can monitor the system continuously and can detect the damages in the system. And the aim of the paper is to find out the state of the art of the structural health monitoring in timber structures. It also covers methods, sensors, applications, and case studies. And the sensor technology varies from strain gauges, accelerometers, to fiber optics and wireless networks to determine strain, displacement, acceleration, temperature, and moisture. And there are basically two kinds, which is embedded and surface mounted. And these are some of the pictorial representation of the sensor technologies. Here you can see the sensors that are actually embedded, which is in the figure 3, and the sensors that are surface mounted, which is in figure 1 and 2. And different types of structural timbers that are used in the market nowadays are cross-laminated timber, nail-laminated timber, glued laminated timber, and dowel laminated timber. And these are some of the pictorial representations of these timbers that are used. And the factors that are affecting these timbers are humidity, moisture, temperature. For example, humidity and moisture increases the fungal growth and insect infestation in the timber structures, and the moisture causes swelling and shrinkage, which eventually causes the fungal growth and insect infestation. So these are pictorial representations of the damages that are occurred in the timber structures. And because of the temperature fluctuations, the timber expands and contracts, which causes the cracks in the timber. And the other factors that are affecting the timber structures are biological attack. Like I said earlier, because of the humidity and moisture, the timber is more susceptible to the fungal infection and insect infestation. And because of the poor construction detailing and maintenance practices, there can be damages in the timber structure because timber is more prone to the decay, and improper ventilation or drainage can lead to increase in moisture, which in turn leads to the decay of the material. So these are some of the pictorial representations of the ancient buildings, which is a church in Poland and a church in Spain and a church in Bethlehem, which have been damaged due to the factors that I've mentioned before. So the sensors use acoustic emission method, which uses the piezoelectric sensor, which use the electricity in order to find the defects in the material. And ultrasonic testing is a method where the sonic waves or the sound waves are used to determine the damage in the timber material. And operational modal analysis is a method where the modal frequencies and mode changes of the mode shapes are determined, and with which the damage in the structure is determined. So some of the sensors that are available are accelerometers, which uses the piezoelectric and piezocapacitive materials, and the other is optical or photometry, which uses the light or the photography to determine the damages in the material. The other one is the fiber optic sensors, which are most commonly used nowadays, and it can be used in the form of embedded systems. And these are the recent developments of the structural health monitoring of timber structures. For example, the building, or 6-story building in Sweden, has been monitored continuously with the use of accelerometers and sensorons, which are the environmental sensors. And another building in Norway, which is an 8-story building, has been permanently monitored with the help of piezoelectric accelerometers and anemometers and the weather station, which has been installed on the top of the roof. And the other studies are the laboratory testing of the timber structures with the use of electrical sensors. The studies that I've mentioned these are the pictorial representations of those studies. For example, the study in the Norway with the 8-story building, they have implemented the accelerometers and the weather station on top of the roof. And the other one is the experimental study where the damages have been determined with the embedded sensors, electrical sensors. And the key outcomes is that use of multi-sensors such as the sensorons, for example, sensorons are the environmental sensors, those can be used to determine the temperature, moisture, and humidity of the structure, of the timber structure. And the other sensors like accelerometers can be used to determine the stress, strain, and displacement. And in combination, it can be used as a long-term sensing elements. And some of the challenges here are the sensors that has to be chosen has to be more durable in terms of serviceability and reliability, and the lack of standardized protocols that are available for the self-health monitoring of the timber structures. And with these studies, a proper sensor will be determined and it will be implemented in the real world applications. Thank you.